Okay, welcome everybody. Here's one last video. I'm going over one more multiple choice question. This is question number 36, and it has an idea that's a little bit different, so I wanted to go over with you. So first of all, there's this method called test. Who knows what it does? Again, don't ask us questions on multiple choice question. It just does something. So basically, at the end, you notice it print lines y equals the current value of y. And then it says, which of the following test data sets would test each possible output for the method? So you think, well, what do they mean possible outputs for the method? Well, what could y possibly be? We have a little cascading if here, so y could be 3, y could be 5, or y could be 1. So what they're saying is, if you were to test this to make sure it did the right thing in every possible situation, there's 3 possible situations. What could x be to make each part of the cascading if be true and therefore give y every possible value? In other words, when would you possibly print out y equals 3? Well, that would happen if x is an even number, right? If x mod 2 equals 0. So somewhere if you were to test this, you would have to give it an even number. We'll look down here, see choice B, none of the choices on B are even. So if you ran test repeatedly on those 3 numbers, in other words, you called test 7, then test 9, then test 11, you would never print out y equals 3. So B, oh gee, what am I doing here? I'm always having difficulty with this writing here. B cannot be the right answer. Bad answer, okay? So we need at least one even number. Then you say, well, when would you ever print out x or y equals 5? Well, you need a number greater than 9, but notice this is a cascading if, so you need a number greater than 9 that is not even, right? Do we see a number here that's greater than 9 on choice D that's not even? I don't think we do. Okay. What are some numbers like greater than 9 that are not even? So odd numbers greater than 9 would have to be like an 11 or something else like that. In fact, if you look at choice A, okay, you need an odd number greater than 9. A doesn't make sense either, right? We're going to look at this process of elimination we're doing. This is great. Okay, then you think, well, when would you ever print out y equals 1? Well, if this is not true, so you need a number that's even, you need an odd number greater than 9, and then you need an odd number that is not greater than 9. Well, if you look at choice D, you get 2 odd numbers, but they're both greater than 9. D is not the right answer. C ends up being the right answer. If you think about it, if x equals 8, you'd be right here and you'd print out y equals 3. If x equals 9, you would jump down here and print out y equals 1, because 9 is not greater than 9. And then if x is 11, you would print out y equals 5. So C ends up being the right answer. Just want to do this one with you because this idea of possible test data sets is a fancy way for saying you want every possible thing to happen. You want every part of the cascading if to happen. What would your values of x have to be? Thanks a lot.